There's only one kind of phosphate that's sold in the world today, mono and diammonium phosphate, MAP and DAP. It's made through a chemical process called beneficiation, but it's made with sedimentary rock, 85% of which in the world comes from the Western Sahara, and in North America, mainly Atafos in Idaho, Mosaic in Florida, and Nutrien in 2 places in the US. It's open pit, and then they have to put it through a beneficiation process to remove the uranium, thorium, cadmium, cesium contaminants. And when they put it through the process, you get a ton of acid and 5 tons of phosphogypsum, that contains all the radioactive materials. So you've got a situation now with Mosaic in Florida, northern Tampa. They've got a hill 5 miles long, 500 feet high, of pure white, radioactive phosphogypsum. So what's happening is the regular MOP and DAP, when you put it on a field, a farmer's field, it rains, it's soluble. And all that phosphate runs off into the rivers and lakes and causes algae blooms. So between the problems with the phosphogypsum, the problems with the algae blooms from MAP and DAP, the ecology people are really upset about it, and so are the politicians today. It could be outlawed in Europe as early as next year. So where are we? Where do we come in? Well, we're organic. So it's very simple. We came up, we encountered this about 12 years ago. I got it from a prospector, Marco Montesinos in Reno. And Paul Pittman, one of my geologists forever, went down, looked at it, and said, Robin, you got to take this. It's organic. It's pure. There's no contaminants. There's no heavy metals. So I picked it up from Marco, and we've had it ever since. Phosphate was a drug on the market until 2 years ago. And once it jumped up, we got some money, and here we are. This is the, it's called the Leech Mountain Trend. It's a whole mountain range. On the left, where you see A and B, that's 6 kilometers of strike. That's our original strike length at surface. It's 4 meters wide, 4 meters deep. It's been trenched and sampled, so that's why we know what the grade is 5 to 15%, P2O5. We know that's organic. It's clean. There are no contaminants. And we did further work from last fall and have seen in other sampling projects, particularly by the U.S. Geological Survey, that takes us all the way around E and G through F, and that is 30 kilometers of strike. And you can see it's like a letter C, and everything dips into the center. So our geologist, Gary Smith, says it's like the crust on a pie, and the middle is the pie. And we figure that the dips at a 27-degree consistent around the edge of the pie. Gary thinks it's a consistent specific gravity of 2.6, and that we're about 150 meters deep. And if you do the calculations, it's 12.25 square miles in that sea, which translate to roughly 225 million potential tons of organic P2O5. To think about that, Atafos is a very large producer, and they're in Idaho. They produce 55 to 60,000 kilotons per year. So this is 225 million. They're 55 to 60,000 tons a year. So there's real opportunity. This is a vertical. This shows you top to bottom what it looks like, and you can see the mountain ranges in between the areas of application. Essentially, you have 2 kinds of minerals in Nevada: locatable, which is gold, silver base metals that you can stake. The phosphate, potassium, and oil and gas are leasable. So then you're subject to the BLM environmental assessment application process. So what we have is we have 4 sets of leases. We had 1, and then we put in 3 more to cover the areas of the valleys, because there's no sense going up another 1,500, 2,000 feet up the side of the mountain, having to drill back down for something that's 4 meters thick, right? 12 feet. And it's fine if you're $2,500 an ounce. If you're 30 cents a pound, the economics aren't quite the same. So the good news for us, when we look at all of this, is that this is what it all looks like. You see the height of the mountains. We're about halfway, 2/3 of the way up the side of the mountain. And again, we're all through the valleys. So we have a real opportunity to be able to mine eventually through a coal seam effort under the mountain. So this shows you from another angle that we're over with the mountain. We're not down in the bottom with the ranchers, so we don't have to worry about that. We're all BLM. And in terms of why we're organic and the others are not, this is the Western Phosphate field. And in fact, it goes all the way north to Sparwood. There's an Aussie company down there called Fertaz that has a small stringer organic opportunity, but very small, very thin, and they have native issues. We don't. So what we have here, you can see that Nevada Organic is on the western side of what was a depository basin in an ancient sea. And Atafos is in the middle of it. And so we think that we have no contaminants because the heavy metals precipitate out at depth of the pond or ocean, whatever bay it is that were ancient that settled it. So that's why we're at a very unique situation. There's nothing else we know of in North America that has this organic potential. Chatham Rock Phosphate in New Zealand has an offshore project. It's about potential 100 million tons, but they can't get it permitted. So this is a real opportunity for us. In terms of shares outstanding, right now we've got 44 million shares outstanding. We've got 35 million warrants, but almost 30 million of those expire in May. So we're looking at a situation where we've got 56 million shares outstanding, fully diluted right now. Stocks and nickel, $2 million market cap, and we've really been range bound for a year and a half since we started trading in February of 23 because we've been subject to the BLM environmental process. So we've had no news. However, we've been talking to the BLM. We're very close to getting our environmental assessment being posted on the BLM website. Then it's a 30-day public consultation. At the end of 30 days, we get our drilling permit. And it's very exciting because then we're going to put in 12 pads, 14 pads on that area A that you saw on the side of the mountain. Not 10 yards long. So we can drill 3 holes off each pad, 14 pads, but initially just the 14 holes to see what kind of depth and consistent we have, because we think the whole thing is homogeneous and contiguous throughout. And we can tell because it looks like a Mars bar sandwiched between 2 layers of limestone, so you can see it. And we hope, we're just going to go drill. It's only 150, maybe 200 meters deep. So from a pad, you're going to drill 1 hole, takes you a day, then you move. The next day, while you're moving it, you split the core, sample it, and send it an hour down the road to Elko, Nevada, to ALX Chemex. So 2 days later, you get your assays. So from the time we actually color the first hole till we get the assays back is a week. I wish I'd be able to move the drill, start drilling the second hole on day 3, and keep moving that throughout 4 weeks, 6 weeks, and end up with assays, maybe 2 assays every week, 2 sets of assays. So this is going to move very quickly once we get permission to go and drill. In terms of the stock now, we're 5 cents, 6 cents. I'm looking to raise a little money here at a nickel with a dime, $200,000 to get us through the process and have some money to be able to put a downstroke on the drill program. And Lord knows where we go from there. But it'll be a great relief to be through this bracketing process of the BLM. So I'm outside. I'm happy to answer any questions you have. I think it's an amazing opportunity, and it'll be the most fun you have this year for a nickel. Thank you very much.